As of now, it is health graph and then oral engine. So it is a critical condition. Graph and then oral engine. Hello everyone. Today we are going to see the project name called Multimodal Industrial Predictive Maintenance using Hybrid Deep Learning, Relational Sensor Modeling, and LLM-Based Explanation. So in this project, it presents a hybrid predictive maintenance system designed to estimate the remaining useful life of industrial machinery using multivariate sensor data. The system analyzes sequential operational signals, extracts temporal and statistical features, and integrates them through a fusion model to generate accurate lifespan predictions. A language model based module is used to produce human readable maintenance explanations and supporting decision making. So, this is the block diagram. First, industrial sensor data. So, it provides the machine's operational readings as the input to the system. Then, data pre-processing here was the sensor data. So it can be used for model analysis. So then CNN model. So processes the data to capture short-term signal patterns and then future extraction generates the statistical summaries describing the machine condition. Relational sensor modeling. So connects the sensor relationship to represents how parameters interact. Then the multimodal fusion block. So it combines all model outputs and features into one prediction process. Based on this model, our system is going to predict the remaining useful life predictions, how long the machine will run. So after that, LLM explanation generator. So it converts the prediction into readable maintenance guidance for the user. So this is our training code. First, we are importing all the necessary libraries. So this is the pre-processing code. So here we are pre-processing our raw data sets and then converting that into NumPy model. So this is our data set. So our data set in the format of txt file. After pre-processing, we are getting the data set in the .npy files like a NumPy model. This is our ML training. So first we are importing all the necessary libraries and then we are setting the path and where the model should have to be stored. So here we are setting those paths. So in that path, we are telling which dataset should have to load for the training purpose. After that, here we are training 4 models: threshold, random forest, CNN, and LSTM. After all models training, we are storing all the baseline training models. This is our fusion model. So here also we are first loading our data set. After loading, we are training first sensor only. Based on the sensor only, we are training and we are storing that model. After that graph model, from the data set, we are only taking the graph. And based on that, after that we are storing the model. And then final multi-model fusion, combining all the CNN, LSTM and sensor-based model, graph-based model and text-based model. All the models we are combining and storing in the name of fusion model. So this is our dashboard. So we are using a Streamlight. First we are importing all the necessary library and then for a human readable language we are using LLM. For LLM we are using hook API key. Based on that our LLM will generate the text. So here we are loading our data set and then along with all the models. So in our Streamlight we have one predict button. If you click that predict button means then in our Streamlight first we need to select the data set. After selecting the dataset, it will ask which engine we need to predict. If you select that engine means then we'll give to our model. Our model will do sensor features and graph features and text features and then CNN LSTM. After that, all the features extractions, our model will predict RUL remaining useful lifetime. And then based on that RUL, if it is a less than 30 means it was a critical condition. It is less than 70 means then we should have to maintain properly. If else means then our engine is healthy condition only. So after that, based on this, our LLM will explain for the humans very clearly what we should have to do. After that, in that Streamlight only, we have two graphs. One graph is scene sensor trend graph, sensor graph, and the another one is the overall engine graph. So we'll run and we'll check it. Run this program, we need to type Streamlight space run space our file name .py. So our file name is a dashboard. Run the program, we need to provide Streamlight run dashboard.py. Once if you enter means then it will redirect to the web page. So this is our dashboard. Multimodal industrial predictive maintenance system. So we need to select the data set. We can select, we have a four data set. From here, whatever we want, we can select. As of now, I'm selecting first data set. The engine number we need to provide. So if you click the predict remaining useful life means, then it will predict and it will give the remaining useful life. So it is our engine is as of now it is healthy. The remaining useful life is 105 cycles, and below that we can see the explanations like here the LLM part is working. So these are all our sensor graph and then overall engine graph. So we'll check with the another data set. So here you can see for this data set and the selected engine number, it is telling like 157 cycles. So this engine also healthy along with the maintenance explanations, how we should have to maintain for the engine. So we'll check with the another. Here we can see the data set for both the data set. We are selecting the engine number as a 69. For that, what it is telling us, it is a remaining useful lifetime is 56 cycles only. So we should have to maintain. So here we can see the explanation based on the provided data. So it is giving the recommendations along with the graphs, overall graph and then sensor trends graph. So here you can see for data set 3 and the engine number 14, it is predicting the useful lifetime 29 cycles only. So it is a critical condition. So here we can see the explanations along with the diagrams. We'll check with the another one. So for a data set 2, engine number 16, it is telling like a 141 cycle. So engine is healthy along with the explanation. Explanation each time it will change according to our prediction. So like that only for graphs also, each time it will change according to our prediction. Thank you.